Recently, there was a bombshell announcement in the scientific community that there's a bunch of smaller objects in the outer solar system that appear to be influenced by the gravity of a massive hidden ninth planet. So this planet is 10 times more massive than Earth. It's 100 billion kilometers away, and it takes 15,000 years to orbit the sun once. So I've seen some pretty impressive videos about the scale of the solar system, but they're all still pretty abstract because they're either using renderings of the planets or they're using objects and distances that have no real-world association. So I'm going to attempt to fix that today by representing the planets with just junk you could find lying around your house, overlaid onto this football field. So we'll start by reviewing the scale of the first 8 planets, and then I will attempt to blow your mind by showing you exactly how far away the newly predicted 9th planet is. If you ask how far away Earth orbits the sun, most people give an answer like this.
Right here, I guess.
And it's kind of understandable. About right there? Because every picture of the solar system ever looks like these, including my own report on the solar system from the 4th grade. So this is the true scale of the solar system, starting with our size 5 soccer ball sun, which puts Mercury at the 10-yard line as a mere fleck of pepper. Next is Venus at the 19-yard line, and it's about the head of a pin. Next up is my favorite planet, Earth. Orbited by our grain of salt moon. So if you retain nothing else from this video, just remember that Earth is the size of the head of a pin, and it's at the 26-yard line. And as the final rocky planet, we have Mars at the 40-yard line, also a fleck of pepper. And now we start to see bigger gaps. At more than a football field away from our sun, we have Jupiter, which is the scaled size of a grape. And after a little bit of exercise, we come to Saturn, which is a slightly smaller grape, and 2.5 football fields away from our soccer ball sun. Next up is the 7th planet Uranus, which is the size of a pea, and its orbit is an average of 5 football fields away from our sun. And finally we come to Neptune, which is also the size of a pea and orbits around our sun the size of a soccer ball, nearly 8 football fields away. Now, this view should help you appreciate the difficulty in accurately representing both the size and distance between the planets in a single image. Okay, so before we get to the new 9th planet, let's recap. So we've got a pepper flake at the 10-yard line for Mercury, and then a pinhead at the 18-yard line for Venus, and then another pinhead for Earth at the 26-yard line, and then a pepper flake for Mars at about the 40. And then of course the asteroid belt, and then we make it to Jupiter, which is a grape at about 135 yards. Then we cross the street to get to Saturn, which is a grape that orbits at about 2.5 football fields around our soccer ball sun. Then we double our distance from the sun to get to the 7th planet, which is a pea, at 5 football fields away. And finally, at nearly 8 football fields away from our sun, we have another pea, which is Neptune. And now we've laid the framework for understanding just how far away Planet 9 is. Because to reach it, I would need to walk, and to walk some more, and to keep walking at a brisk pace for 5.5 hours before I finally reached the P that is Planet 9. And while, of course, you can't see it, you'll just have to take my word that directly in front of us, 17.5 miles, or 309 football fields away, there's a yellow size 5 soccer ball sitting in an end zone. In fact, the width of that column you see represents the extent of our entire solar system as we know it today. From a different perspective, this would be your view if you parked your spaceship halfway to Planet 9. It blows my mind that, relatively speaking, our sun, 17.5 miles away, would be able to keep this P in orbit. But what's just as fascinating to me is when you consider that in our scale model, the sun is represented by a soccer ball, which anyone could easily fit inside a soccer goal. And yet our massive star we call the sun is pretty small when compared to some other stars. In fact, the largest star we know, next to our soccer ball-sized sun, would be as tall as the Empire State Building. So I want to close by telling you guys the craziest thing I learned about space while working at NASA for 9 years. 20 years ago, astronomers did something pretty risky and decided to point the Hubble telescope at the darkest patch of the night sky for 10 days. Now this was risky because time on the Hubble telescope was extremely limited, and there was a good chance the image would come back completely dark. So they started exposing the shot, and for 10 days, photons entered the telescope and ended their journey of billions of years on Hubble's CCD detector. And at the end of 10 days, this was the resulting image. With the exception of these single stars, every speck, smudge, and spiral you see in this image is a galaxy with hundreds of billions of stars, just like our own Milky Way. And what truly makes this mind-blowing is the portion of the sky represented in this image is the size of Roosevelt's eye on a dime, held at arm's length. To think about it another way, there are more stars in the universe than there are grains of sand on all the playgrounds, beaches, ocean floors, and deserts on our planet. So next time you're near some sand, take a handful and just imagine that one of those tiny grains is our sun with its orbiting planets. And then look at the hundreds of thousands of additional grains of sand in your hand, each with their own orbiting planets. And then while holding that, contemplate how many handfuls of sand exist on our planet. So in my mind, regardless of how you think this whole universe came to be, there seems to be an infinitesimally small chance that we're alone.
Make someone's year by donating in the Arroyo Seiko Holiday Toy Drive. Donations will be accepted at Arroyo Seiko's front gate until Friday, December 18th. Only toys that are slightly used or new will be accepted. All collections will be given to people in need.
Thank you to everyone who participated in Project Give. Our raffle winners are going to be Audrey and Tristan. Congratulations.
Hi Seiko, join ASB today and participate in a sports-themed Kahoot to test your sports knowledge and earn yourself a chance to win a prize. The Kahoot link will be posted in the Spirit Google Classroom at 12:15. We hope to see you there.
Hey everyone, welcome to the Asb Raffle Spinner. We are going to finally pick the raffle winners. Luke, spin the wheel. And the first winner is Evan Lemon. And our next winner is Savannah Sedek. Neil Aspert. Sorry if I pronounced any of your names wrong. You will receive your prize shortly. Thank you all for playing, and make sure to join us next time. Bye, everyone.
Attention all Paintball Club members! Our next game will hopefully be on Saturday, December 19th. If you are interested, please email Mr. Fernano at mfernano@heartdistrict.org. All students and teachers wanting to go are very welcome to. Anyone not in the club and interested in going out and safely having fun playing paintball, please join our Google Classroom with the code VCWDEV2.
Congratulations to our Seiko student shoutouts. We are so proud of your hard work. Keep it up.
When you dance.